gives me great pleasure to welcome Dr. David Khoza from the Council for Geoscience here. And I just want to point out that David is one of the few people I know of that has gone to industry and then come back to academia and then gone back to industry and is now in government. And it was a very sad day for me, actually, when he graduated from honors. And he said, no, I'm going to go work for BHP, and disappeared. And he just disappeared for years. And then all of a sudden he came back and wanted to do his...
I do that once in a while. Just
It was really amazing. I was just so shocked, because we often advise students not to do that because it's very rare that people do come back. But I wanted to show you a living example of someone who's done it and done it very successfully. And so I was one of David's PhD supervisors, and so I'm very proud to see him being so successful. And I'll leave it at that. If you want to read the details,
yes.
Otherwise you have to listen to me reading, which is always awful. So thank you, and over to you, David, and welcome back for an alumni talk.
Sure, excellent. Okay, let's see. All right, so I have to stay here, I'm told, so I can't move around, right?
Yeah, the microphone. Yeah, they probably didn't hear me, although I'm pretty loud.
That's all right. Okay, thanks for the invitation. Good afternoon, everybody. Switch this off. Okay, so I hope I'm not going to be too long, but the talk is essentially on our role as geoscientists in achieving these net zero goals. We all, people have been talking about this net zero for a while now, and it's good to find relevance in these type of topical issues. Let's just say, don't quote me if I'm saying anything weird. Just start with the important things. So the CGS will be hosting a geoscience summit. You're all invited. Registration is free. This will be in Durban around October. So you can check the website there. Okay, so net zero. We all know what the issues are when it comes to climate change. I think there's no scientific doubt that humans over the last couple of years, we've done some things to the climate in terms of carbon emissions. And countries essentially came together and developed some sort of a roadmap that will regulate the global energy sector. And this is to get to a point where us as citizens of the earth, we can get to this net zero scenario where we do not emit carbon emissions largely, but there's other emissions as well. So this is the ideal scenario, that we're going to reach net zero in terms of emissions by 2050. And this slide here shows the pathway. Essentially, these are interventions that need to happen over the next couple of years in order for us to reach this net zero. And you can see already that we have missed some of these interventions. 2021, no new unabated coal plants approved for development. Many countries have approved these and continue to approve these. So it's highly unlikely that we're not going to reach net zero by 2050, right? I'm just highlighting here in red some of the critical ones. You can see by 2035, no new internal combustion engines car sales. So that means all the cars that we're driving now should all be electric by this time. 2035, capturing about 4 gigatons of CO2. This is, I'll talk a little bit about this later. And then around 2050, 70% of all electricity generation should be from solar and wind. Okay? Again, in my view, this is all pie in the sky, but it is an objective nonetheless. So that's net zero. In many other countries, and including South Africa, we talk about just transition. And so just transition, in essence, is we recognize that we have to transition to a low carbon economy. right? So what that means is that we need to take into consideration issues around, socioeconomic development and things like that. So in South Africa, this issue of just transition is probably more important in a sense that we generate a lot of our electricity from coal. And we're going to do that for the next few years, right? That's not going to change. Most of our electricity comes from Mpumalanga province. This map showing the locations of all of the Eskom power stations. And a lot of these power stations are planned for decommissioning in the next 10 years. And obviously this will create a whole lot of problems because there are people who are employed directly by these power stations. And this is directly and indirectly. And so the coal sector employs quite a lot of people. So now if we're transitioning to this low carbon economy and closing all these coal power stations, we need to think about what impact that's going to do in the communities around. And we've seen it in the closure of gold mines and things like that. So this is a serious problem for us in South Africa, but we've made some commitments. We've made commitments to reduce CO2 emissions by half in the next 10 years. Also, that's probably not going to be reached. That's still a pie in the sky for now. But we still remain one of the large CO2 emitters, the largest CO2 emitter, certainly in Africa. So in making these commitments, we need to recognize that we need to put together some sort of strategies and policies on how we will not do negative harm to the environment. Now, in terms of low carbon economy or reaching this net zero, there's also recognition that there are technologies that are needed for us to reach this low carbon economy, and those technologies require minerals. Right? So where are these minerals? So what are these minerals? Where are they going to come from? And these are some of the few that are listed here: your lithium, your cobalt, graphite, and things like that. The recognition is that we need to mine our way to net zero. Right? That's just a fact. We cannot be developing electric vehicles if we do not have minerals. So these are some of the minerals that are needed for the different technologies, whether it's wind, solar, electric vehicles. We do need these minerals. And the sad thing is that some of these we are running out of rapidly, and we're not finding enough of them, copper being one of them. So you usually hear people talking about critical minerals and strategic minerals. In the South African context, mineral would be strategic. We have it in abundance. We have a dominant position globally that we can pretty much control the market, right? But if you're talking about a critical mineral, it is of economic importance to a particular sector in a specific region. So this is a graph that shows who dominates which minerals. Everything in red is China. Okay, so China controls pretty much most of the critical minerals that we need. If you look at rare earths, graphite, all of these things, we come in there with PGEs, but you've got Australia, DRC also having critical minerals that are needed. So what we are seeing more and more of is, this notion of resource nationalism. So countries know that they've got a lot of minerals in supply, and they're using that to achieve their geopolitical goals. And China is certainly doing that effectively. Most of the minerals, critical minerals that we need, are actually minor commodities. So if you look at it in a mineral systems context, if you look at a lead, zinc, silver type mineralizing system, 75% of indium would come out of that system. And you can do that with all the other mineral systems. So they're actually minor commodities. And countries have developed their own critical minerals lists. They're all broadly kind of similar. There's not much difference between them. And more, you'll see that all the countries that basically have a yes in all of them, all the minerals of the periodic table. So that's just the story there when it comes to the dominance. Now, as I mentioned, most of the elements in the periodic tables that are essential to this net zero, to achieving this net zero goals. Now, when you look at the demand of these minerals, there's a whole lot of minerals that are needed. But lithium, REEs, cobalt, nickel, copper, these are the ones that are really, really critical when one looks at the technologies that are needed to achieve net zero. We have to find them, and we have to find them somewhere. My belief is that Africa is the place to find these minerals. And if you look at where most of the operating projects are, those under development, there's still there's a lot in Australia, obviously, a few in Africa, and this map I think will change in the next couple of years. Okay, so now that's pretty much on net zero and the type of material that we need to achieve those objectives. So what do we have to do? Where do we fit in all of this? So here's that pathway again. I mentioned that in 2035, there's a dream to have 4 gigatons of CO2 captured, okay? So what does it mean for us? In the South African context, as I mentioned, we know that we are emitting quite a lot of carbon and other greenhouse gases. We have the single largest point source emitter of CO2 being the Sasol Secunda plant, and that is emitting quite a lot of CO2. So in terms of capturing the CO2, the process is actually very simple. You have a power station or a coal-fired power station or a Sasol Secunda plant that emits almost 90% pure CO2, right? You capture that CO2, you transport it to a suitable geological storage site, and you inject it and store it underground and hope that it stays there, right? So that's basically what the simplified version of carbon capture. I've highlighted here in red the utilization aspect. So carbon on its own is actually good, right? The problem is that we have a lot of it, CO2. And we don't want that. So we need to find ways in which we can utilize the CO2, right? So some of these fizzy drinks that we drink here, there's a whole lot of CO2 in there. So we need to find ways in which we can utilize it to make it economically viable. So carbon capture and storage on its own, there's no incentive for doing it. Right? There needs to be some sort of a commercial benefit. Nobody's going to fund you to put CO2 on the ground. It's a nice thing to do, but there needs to be some sort of a commercial benefit. Right? So in South Africa, we've been efforting this program for the past couple of years, and we've selected a site in the Mpumalanga province. So this is Sasol Secunda plant, and the idea is that we capture the CO2 from this plant and inject it underground. Now, obviously, you don't just inject CO2 everywhere. You need to find a suitable geological storage site. And this is where we come in as geoscientists. Right, so we've selected a site here in Leandra. Sasol Secunda plant is sitting here. It's about 30 kilometers from Sasol Secunda plant. So we'll have to basically transport CO2 from this plant to that site. Now, why did we select a site there? Before I get there. So this site is pretty much on state land. The town of Leandra is to the south here, and there's nothing there, essentially just a bunch of cows and goats. So we looked at, we basically did a study of the whole of South Africa, starting to look at where would we store CO2. We looked offshore, onshore, different geological settings, and we settled on this site for 2 reasons. Well, firstly, because we think it can work, but also it's closer to the major carbon emission sites, right? So if you are going to transport CO2 over long distances, it might make the program not economically viable. So we looked at what information is available, existing borehole data, existing seismic data to select a site. And we've settled on a particular site targeting specifically the Ventersdorp group lavas, right? So what we did is we looked at all the boreholes. we looked at the seismic data. We looked at all the airborne data, the urban geophysics data that exists there. And this is some of the locations of the holes. And kind of develop some sort of a conceptual cross-section. And this is the target horizon. This is the porphyritic lavas of the Ventersdorp group, overlain by the Transvaal and the Karoo. So the idea is that we inject CO2 at about 1.2 kilometers in the Ventersdorp lavas. So we've done quite a comprehensive set of studies on the existing boreholes, including hyperspectral core scanning. And this really gives us information on the spectra of the different minerals in the rock. And that allows us to characterize the different subgroups within the stratigraphy. So what we've also done is we've flown airborne electromagnetic surveys, largely from a structural point of view to understand the basement topography, groundwater, and the Karoo geology. And we just got this data about last week or so. So this is the NRG's Excite system. I have not looked at this data, I only looked at it last night. So you are the first to look at it like this. So it's hot off the press, different magnetic and radiometric data sets. And the different depth slices. If you take the 3D conductivity map, generate a bunch of depth slices. So already there you can see a bunch of sills and dikes and interesting features that probably could relate to saline water. So there'll be quite a lot of modeling that has been done on this data to understand the stratigraphy. Next would be the seismic surveys, reflection seismic surveys in particular, and this will be coming in the next couple of months, and that will basically result on the drilling program. The idea is that we drill 3 2-kilometer holes to characterize the stratigraphy. So this is really the role of geologists and geophysicists when it comes to carbon capture. Just for your interest, because this is really the first time that we do it in South Africa, there's still quite a lot of knowledge gaps that we have to fill in and research that needs to be done. And this is, in the next couple of months, we'll be having some research bursaries, if you like, focused particularly on carbon capture technologies, utilization technologies, and storage options. Part of the program is to monitor what you're doing. So we would like to do pre-injection monitoring and post-injection monitoring, pretty much through the lifetime of the program. And this is looking at how the CO2 migrates underground and a whole bunch of other things. Right, now we talk about, back to this pathway, 70% of electricity generation globally must be from solar PV and wind. Again, my view, pie in the sky, but it is an objective nonetheless. When it comes to offshore wind energy in South Africa, in the East Coast, we've got one of the fastest moving ocean currents. This is called the Agulhas Current. And it is an option to exploit in terms of wind energy. So the idea is that we put some of these type of ocean turbines on the ocean floor to generate energy. It is not something that hasn't been done before. The Japanese are busy with this type of thing on their coast, putting these big ocean turbines offshore. So we're hoping that we might be able to exploit the Agulhas current for this type of thing. Now, you don't just put these ocean turbines anywhere in the ocean floor. You need to understand what the sedimentary sequences are on the ocean floor, the basement topography, and all of those things. So this is the work of geoscientists when it comes to wind energy. At the CGS, we recently bought this marine vessel, which we call RV Nkosi. This is a marine mapping vessel, primarily for nearshore mapping, so to water depths of about 100 meters or so. And we collect a whole bunch of things in there, particularly multi-beam bathymetry. What I'm hoping we'll get in the next couple of years is to get magnetics and electromagnetics as well, particularly for deep offshore mapping. So this is one of the examples of the map that we've produced using this type of boat. This is a bathymetry type data. There's Robben Island, and this essentially shows you, the depth of the waters, if you like. But you can see other things in the data. There's like lots of shipwrecks. There's thousands and thousands of shipwrecks that we're able to spot from these type of data. And if there are people who are crazy enough to do deep diving in these things, they like this this sort of thing. So this is excellent information, firstly, to understand the structures that are on the ocean floor. Some of these extend onshore, and to understand the depth of the water column. Okay, geothermal energy, it's also listed as one of the interventions in terms of reaching this net zero. But it's listed in this report that we need to do more when it comes to geothermal energy. In Africa, Kenya is the leading, I should say the leader really when it comes to geothermal energy, globally even I should say. So in South Africa, do we have this type of energy system? So a couple of years ago, this map was produced that essentially was showing the geothermal gradient, highlighting hotspots that we could possibly target. And we selected 2 sites from this map, one in Limpopo and one in KZN. But there's other sites that we can look at. So in essence, we are targeting hot rocks at a specific depth that we could exploit to generate geothermal energy. And we've done a bunch of studies in 2 sites. So this is a site in Limpopo targeting the hot springs. This is the Chipisa hot springs. And in there, we collected a whole bunch of data. This is a magnetotelluric section that shows resistivities. Blue colors are resistive, red colors or warm colors are more conductive. And we developed this kind of a conceptual model of what we think where we think the hot waters come from. So the idea is that you have this type of energy systems where you inject some sort of a fluid, it gets heated, comes up to surface, puts into a heat exchanger, drives a turbine to generate energy. So that's the intent. And then this is a site in KZN. So King Shaka Airport is there, the site is there, pretty much on the Tugela River. Okay, so that's the Tugela River there. We collected another interesting data sets, including magnetotellurics, which is my favorite, but there's other data sets, magnetics and electromagnetics. There's been some conceptual models that have been developed as to why the hot springs are there, at least in that part of the world. In KZN, there's some thinking that in the Drakensberg foothills, that's the recharge area. This water travels kilometers and through faults until it gets to where the hot springs are because of pressure changes. So this is the one model that we are testing, and we hope to report on that soon. Yeah, so again, we've collected a whole bunch of data. So we almost seeing some sort of a plumbing systems from 2-kilometer depth that is transporting these hot fluids. Sorry, I don't have a scale there, but yeah, again, red is conductive. Okay, now, in my view, in order for us to reach net zero, we need nuclear energy. We cannot reach net zero without nuclear energy. In South Africa, we should have done this already in 1994, but we didn't do it. So our role as geoscientists in terms of nuclear energy is, well, first finding the uranium, but also assisting in managing the waste that comes from the nuclear power stations. So for those who don't know, we do have a nuclear power station. It's called Koeberg, sits there in Danafontein, it's north of Cape Town. And this site is run by Eskom. It's been going for a while. The problem is that the operating license of this site is expiring. In 2024, if we do not renew the license, the government will shut this site down. So it can be extended, and that's where our role as geoscientists comes in. And the idea is to conduct, or part of the renewal application is that we need to conduct probabilistic seismic hazard assessments and create or develop a tsunami source model. Obviously, with issues that have happened before in Japan, we'd want to know that should there be a tsunami somewhere, would this site still be there? So this is the work that has been done, and it's done mainly by the seismologists in the Council for Geoscience. And we have to submit this safety case, I suppose, in next year, pretty much. And ESCOM needs it so that they can submit their application to the NNR. So what we've done in this side, we've conducted a whole bunch of studies: geological mapping, structural mapping, paleoseismicity, all of those things, to build a probabilistic seismic hazard map. So Quebec then burns the fuel, and now you're left with the waste. So what should they do with the waste? Currently, we are storing it underground in this nuclear site. This is in Farpets, in the middle of nowhere in the Northern Cape. So ideally, or not ideally, but what has been done now is that this spent nuclear fuel is put into drums and is put underground. Now, you don't just put this type of material anywhere, right? So you need to find a suitable geological storage site to store this type of material. And this requires us to understand the stratigraphy, structures, the basement, all of those. You obviously don't want to put it in a site where that's susceptible to seismicity, for example. So this is where the site has been developed in Farpets. And in essence, they put the drums in there, put a lot of sand, and put a bunch of concrete, things like that. There will be, in my view, there will be more. There will be additional nuclear build in South Africa, so we need to find more of these type of sites. And the geoscientists are critical in informing where to store safely this nuclear material, and it's rehabilitated afterwards, so you can grow some plants. I don't know if I want to eat the bananas from there, but that's just me. So yeah, so that's a a typical I suppose a typical framework where you burn off the uranium, take the spent fuel and store it underground. So this geological repository needs to be a good site from a geological point of view. Okay, so we spoke about minerals of the future. I think this one is fairly simple. As I mentioned before, we need a whole bunch of minerals. And we need to find them, and we need to find them very, very quickly if we are to achieve net zero. Mining companies are now directly supplying electric vehicle manufacturers, such as this deal made by Tesla with BHP. In South Africa, mining does matter, as we know, even though it has been on a decline, but it does still matter. That's 460 people directly employed by the sector. Can think of the indirect contributions there. We know that we have a lot of these minerals, but we just have to find them and find them quickly. And globally, when you look at the contribution of mining to the national economies, pretty much everything in gray, dark, that's where mining is important, right? So it's important pretty much for most nations around the world. As I mentioned, it means that for us to reach net zero, we need to dig this stuff up. It's difficult because most of the obvious things have been found. Most of the obvious deposits have been found. If you drive in the Northern Cape, this is the type of setup that you are seeing. It's nothing basically for miles and miles. So we need to use technologies that allows us to see under this sedimentary cover. And we know we have those technologies. They're not very, they're not complicated, right? So finding these minerals, we are faced with a lot of challenges. And I've highlighted this one in red in particular. Globally, we have a problem in terms of geosciences, right? A lot of departments are being closed. Research funding is limited. And I think, if we're not careful, we'll probably have the same thing here. We probably already do have it. So this will lead to us not having enough geoscientists to do this type of work. Now, that is a serious problem, and one that I think needs almost like a national effort, pretty much. So universities can't do it alone. So, and we know that also finding this stuff, industry is also not spending a lot of money. And yeah, as I mentioned, there's a whole bunch of other things in terms of the political environment and all of these things. But we do have technologies to find them. You look at any mineral in the periodic table, pretty much we can indirectly and directly find it if we apply the right type of technologies with airborne geophysics, mapping, the proxies that one might need for mineralizing systems point of view. And we've done this in South Africa. So we've asked the geoscientists that you need to contribute to us finding these type of minerals. So we've collected a whole bunch of, especially in the Northern Cape, because that's where the next mines, in my view, are going to come from. This is electromagnetic surveys, MT sites that have been collected, and hyperspectral data. And this map here is essentially a conductivity, not a conductivity, it's an overburden thickness map. Okay, so the thickness of the sediment, basically where it's red here, the sediment is like 200 meters thick. Right? So these are the type of challenges that you sit with to find these minerals undercover. And the idea is to be, you want to hone in on specific areas that you can drill to test, especially from this mineralizing systems approach, where you're trying to understand the regional picture of where, in this case, the SEDEX deposits might be. Lithium is a critical mineral. So in South Africa, the geoscientists have mapped these lithium-bearing pegmatites, also in the Northern Cape, and developed this pegmatite density map. In essence, that shows areas where you're most likely to find pegmatites that host lithium. So this is the Orange River. So in Namibia, there are already operating mines exploiting this lithium because geology doesn't know political boundaries. We have the same geology as in Namibia, and we think that a lot of these deposits are sitting on the South African side. So this Orange River pegmatite belt, we've extended by about 67% through mapping. So hopefully this will be exploited by minerals explorers. So I like this geophysical sustainability atlas. I'm sure you've seen it, but it doesn't actually have to do only with geophysics. One can put geology or whatever onto it. But in essence, if you look at the United Nations Sustainability Development Goals, you find geosciences expressed in there. There's no way you're going to find water if you don't do geoscience. Like, no way you're going to find minerals or energy systems if you do not do geoscience. The good thing is that we have the tools. We don't necessarily need any new tools, to contribute to these sustainability development goals. The CEO of the Council for Geoscience likes to say that geoscience is the fulcrum of human development, and I actually think if you can't grow it, you mine it. Right? So we know where geoscience fits in the bigger picture. I'm sure you all know about the geoscience data portals. I don't have to tell you about that. You can get a whole bunch of information there. Okay, that's it. Thank you.
A topic very close to my heart. Sustainability. I'm currently serving on the sustainability committee. I'm roping David into another talk.
David, thanks for the talk. I'm just wondering, can you give more reasons as to why the Fences Door lava was selected as a stored part? Anything particular about the topologies, about the depth, about structures that we have in the selected?
Yeah, I guess I need to ask what the seal was on them.
Yes, very good question.
Oh, so
should I repeat
the question?
Okay, so the question is, what was the criteria for selecting the Ventersdorp lavas, in essence, right? So, actually, the first thought was to store this thing in the vets below the Ventersdorp. And then we looked at the boreholes and saw gold in the cores. And then we went back to our bosses who said, well, is it gold or carbon? What do you want? And they said, whatever you do, do not inject in the vets in case you sterilize mining. Go find other things. So we then looked at the stratigraphy again, and then looked at the porphyritic lavas in the thunderstorm. So the experiments that have been done recently is, it's actually not the first. I think there's a site in the US and Iceland where they're injecting CO2 in the lavas. So they are porous, and we think, at least in this case, they're probably about 800 meters thick. We can initially store about 50,000 tons initially as a pilot. If it does work, we can obviously extend it because they're quite extensive, as you saw on that map. So it's pretty much, this is the estimated extent. So the porosity makes them attractive, but also above and below the thunderstorm, the petroleum geologists would refer these to like reservoir seal pairs. There's a whole bunch of aquifers that we like, that we think if we inject the CO2 there, there's no way that it'll go up, assuming there's no structures. So the porosity is one, and then the thickness of the thunderstorm was another, at least from a storage point.
But is there enough permeability for it to be injected laterally?
Yes, yeah. So that's one of the experiments that have been done to, in essence, take a lava, put CO2 in it, and see how it's going to react. We think it's going to become a new type of, well, we know it's going to become a new type of some new type of mineral. So not necessarily like a hole in the ground or anything like that. So there will be, yes.
Just to add on that, I think in Iceland they're doing this. I think the idea is that you're reacting CO2 with the basalt to make like carbonates. And just on a similar note, is it I was just wondering if you knew if the South African government is considering like direct air capture, so instead of just doing, so in Iceland they're using geothermal energy basically to power direct air capture. That's getting pumped up and down. I'm wondering if the South African government is thinking at all about this in like, I don't know, the Karoo or something, we've got abundant solar energy or something like that.
Yeah, so that's a good question. So we're not looking at it directly, but the CSIR I know is. Okay. And there are people there who are looking at DAC in particular.
Just mentioned there was direct air capture.
Yes, direct air capture. The question.
Hi, David.
How's it?
Sorry for coming late, but I was quite.
No, we have to wait for you. We waited for you.
My question basically relates and then to the plan. Why didn't you also consider in Mati where the first point was CO2 coming from coal mine? That was the issue. Because the study that was actually being involved in the PhD facility in Australia, where we contain materials much better setting there where you can actually directly inject the CO2 into the tailings, and with the greatest amount of scale you can get into such and convert as much of the CO2 into the colonies. How much do you guys consider looking at tailings which is for the greatest scale?
I think so. The tailings are one area that we are actively looking at. Nkomati, not necessarily, because we had to look at pretty much the whole of South Africa and pick one site, right? The biggest storage potential sits offshore. But from a pilot point of view, to transport CO2 from Mpumalanga all the way offshore just makes it not commercially viable. But from a piloting point of view, so this site made a lot of sense. Eventually, we will have to look at other sites, including enhanced geothermal energy and all of these things, in parallel to CO2.
So in the Mati, I was saying sort in a way that you looking for a point source CO2 and then you don't transport the CO2 and close with the automated tailings that are already big. So basically the logistics being cut out.
Yeah, well, even here you can say logistics is cut out. 30 kilometers is not a big distance.
Good question, yes, go ahead. Yeah.
Does South Africa have uranium? Yes. A lot.
Why they really shift into nuclear energy?
Yeah, I'm confused too. That would be my, to me, that would solve all our energy problems.
They have control over what happens in the country.
What do you mean? Renewed license of Quebec? Well, it's a safety thing, right? So you,
By the government, right? I think the
So-
South African government is the ones that are saying, making them.
yes. So we have, remember in South Africa, so we have rules, right? So there's an NNR that regulates, in essence, nuclear energy in South Africa. Every nuclear program has to be reported to them. That it's not a bad thing. It's actually a good thing that you have somebody policing what you're doing, right? Especially if you're dealing with things like nuclear. So it's actually a very good thing that you have to demonstrate a safety case that you have taken into account all aspects for you to develop a nuclear power plant. It's global practice. It's a very good thing. It's not a bad thing. Sorry? NNR.
Yeah.
Nuclear and nuclear
Regulatory.
NNR. It's called NNR. Yes, South African entity.
For geologists. Okay. Geology follows the whole economy first.
Yeah, it's a global problem, right? In terms of research funding, it's not only us. It's worse for us because our economy is not growing. But there are geoscience departments overseas that are closed. University departments in Australia and the US. It's terrible. So unfortunately, that's the reality we are sitting with.
A research facility for geologists in America that are past years. Why?
So geoscience, I mean, we have to learn from each other, right? So there are people who conduct fantastic research overseas where we learn from them. We do fantastic research here, that they learn something from us. It's a community, you can't. You may think it may not necessarily affect us here, but in a way it kind of does, because if you do not have a geoscience community thriving globally, how are we going to sustain the work that we do here?
You can also have a brain drain where companies overseas coach students in talent from South Africa and take it away.
I just wanted to add to that. I think it's a really good question. South Africa, we should learn why those parts of the people are global.
Yeah.
Think about what we should be doing here. Different. Continue to get funding. Continue to get students.
That's a very good question. And in South Africa, we have multiple problems, right? If you are faced with a question of funding housing versus you guys who sit here as a politician, what are you going to do? Exactly, right? So people want to see, people complain. They're not complaining, oh, geoscience is closed. They're complaining about, I don't have a house. So, yeah.
Reese?
Thanks, David. Can you comment on the development of natural gas resources in the country and how that comes into the energy mix? I noticed it's absent in the presentation.
Yes, was deliberate. So the question is comment on the natural gas. So we do have gas in South Africa. I think the whole problem with the energy sector is that it is really the only voice that has been heard is net zero, environment, and all of these things. If we were deliberate as South Africa and recognize that we need energy, without energy you cannot develop, we should be exploiting these natural gases. There are ways in which we can do this in a much more efficient manner. But the current problem we have is that we certainly do not have enough energy sources. I think the gas prospects that we have, both onshore and offshore, needs to be exploited. And it's one of the few ways in which we're going to sustain, I think, even the geoscience sector. So you look at what happened in the environmentalists stopping the seismic survey in the East Coast. So if you do everything right, that doesn't have to happen, right? There's a whole other reasons, but if you do everything right, it doesn't have to happen. And we're gonna leave those things in the ground. We're gonna still complain about load shedding and all of these problems. And we're just gonna leave it there and have an economy that's not growing. But that's my personal. So can you repeat the question?
Has there been any reference back to the goal of continuing set to why we're going to make those going on?
Yes. I think
Just
Sorry.
So yes, so the question is, has there been research into why there is less skilled geoscientists? I think we have to be honest and recognize that we've actually lost a lot of human capital in the geosciences. Right? People who are really very experienced, and you can go into any mining company or exploration company, they will tell you the exact same thing. That is gone. People have left, people with real skills have left. And now you're sitting with a large majority of geoscientists like yourselves who are inexperienced, as in they haven't been exposed into the industry yet, and there's a lot of them. And then you have a very small majority who are close to retirement, and a lot of them have left. So, and we have the same problem even at the Council for Geoscience, where a large majority of scientists are, junior, if you like, want to put it that way, and we have a critical mass at the top who are very, very few. When we do advertisements for senior scientists or chief scientists, we get probably around 300-400 CVs, right? 90% of those CVs, they do not meet the criteria. Maybe our criteria is too stringent, I don't know, but they do not meet the criteria. And you don't have to go far. Look at women, Black women in particular. If you're looking for a Black woman who holds a PhD in geology in South Africa, there's not many, right? So some might be in universities, some might be in I don't know, one in industry, but there's not many. So you have that gap that you need to fill in, and that can only be filled in when you have a growing economy. If you have a growing economy, it means there's much more activity in terms of exploration and mining and these type of projects that I'm talking about. That basically means people are getting more experience, they're exposed to new techniques and technologies and things like that. So I think the fact that our economy has not been growing for a while is partly the answer. And yeah, it's really sad, when I look at these CVs and they're just not there. We get actually more people from overseas applying, meeting the criteria than South Africans.
I think let's go to the online questions. Louis Polome asked, great presentation, a lot of good issues we need to. And geoscientists mostly have all the tools for that. And then from George Henry, are the CGS geophysical surveys in the Northern Cape completed? And when will the data be released?
That's a good question. So the surveys are done. We're hoping to fly new surveys, at least in the western part of the Northern Cape, eastern part of the Northern Cape. We're still looking at the data that we collected a year or so ago. I'm hoping that in the next year it will be available, at least the airborne geophysics. Oh yes. Maybe let's not mention.
Speak up.
Hey, I'm just a geoscientist. I don't represent the government per se. So I don't know. I don't know if there's a strategy like that to shift from, or to hydrogen powered cars. I don't know, to be honest.
Do you think in the future the economy platinum features?
It does. Yes.
Oh my gosh.
Yes. September. Yeah, September. That's when the call for these things. September. That's it.
That's two, and
I agree. So my question relates to the southwestern part of the country, like we find the ones and nines, we different red elements. But what I've realized that most of the mapping is done in the northwestern section of the media, and there is quite specific interest in the southwestern of the house, or Northern Cape next to the Western Cape, where you find these specific. Is there any interest of changing doing a detailed mapping for those particular red elements?
Yeah, so the mapping program essentially started pretty much close to the border following that belt. The idea is to go south, not just on a geological mapping point of view, but also from a geophysical data collection point of view. So the extension of the survey should be to the south and to the east.
Yeah, so just I guess this is more of a comment, but the one critique people have about nuclear, the whole nuclear application is that, what's the model suggesting that we have to make major CO2 reductions within the next 20 years. People say like 2035, we already need to dramatically reduce our CO2 footprint, and it takes about 20 to 30 years to build a nuclear power station. So by the time those, certainly we should build them, but maybe that's not going to be the solution, but
unless you're China.
yeah.
So it can be done. China has shown the way, right? If you throw money at this thing, you can build these things. It doesn't have to take 25 years, right? So they are bringing these things online very, very quickly. So if we're serious about energy security, that's what we must do.
well, please join me in thanking David again.
Yeah, you can share the presentation if you like.
Thank you. Brett, do you have the next one?
The next big speaker is Paul Humphrey.
Wow.
Round speaking.
Wow. Okay, fantastic. Thank you, everyone.
Thanks very much, everybody.